Climate change is only one of the drivers to how river flows might change in the future. Certainly, land cover changes the evaporation that you might see from a land surface. So forests typically evaporate quite a lot more than agricultural lands. So it's been very important to firstly provide the models with good land cover estimates, and secondly to try and ensure that the models we use are actually representing the evaporation in the correct way. So one of the things that Watch has produced is a new global assessment of evaporation, and in fact the group in Amsterdam have put a lot of work into producing a new global estimate of evaporation, making the best use of satellite measurements and also the global databases that we have, and a whole range of other measurements to produce the best assessment. We can then use that to both test how well our models are using and look at and actually try and improve those models. The other important, lost my thread there, but another important driver to the hydrological cycle are the extractions for agriculture, and this is for irrigation. Quite a small proportion of agricultural land is irrigated, but in some areas the proportion is very high. I mean, certainly in places like the Ganges Basin in India, up to 70 or 80% of the land is irrigated. This has a number of effects. Firstly, the extraction of water from either the groundwater or the surface water system can and does cause very big changes in the flow regimes and the groundwater levels in those areas. But also by continually putting water on the land, you're increasing the evaporation. That has some quite interesting feedbacks to the atmosphere, and there's good evidence that actually you can increase the rainfall in a region by irrigating very large areas, and Watch has been looking at that primarily through models, atmospheric models, to try and look at that feedback. It could be important because it means essentially that you need less water in that to irrigate an area if you have large areas for irrigation. So this is all part of trying to understand what the impact of this changing land use, changing water extractions might have both locally and also regionally.
Watch, when we talk about water resources, are we talking about primarily river flows, or is there some account taken of the amount of water that's available in groundwater?
Yes, no. We need to consider both river flows and groundwater and the interaction between those. Certainly, we are less developed in linking those two. The groundwater models and surface water models have tended to come from different communities. So we've been working hard to try and get a better representation of groundwater in some of the hydrological models, and vice versa, trying to, for example, get better evaporation estimates into the groundwater models.